grams as canceling and brought us into the mole. Very clearly, the definition of molarity says it's big M moles per liter. I'm going to just set at under a 1 so I can divide moles per liter. Trick here is they gave me a milliliter. 200 milliliters converted to a liter. I know that there's 1,000 millis in a liter. That prefix milli stands for 1,000. So 200 divided by 1,000 is really just asking you to slide the decimal 3 spots to turn that into a liter unit. Moles per liter to get big M. 200 divided by 1,000 turned milliliters into a liter unit. 3-place difference from milli into the liter base unit. A little crash course in metrics. Let's hit for 3.4 divided by our molar mass of 17.03. Divide again by 0.2 liter units. This concentration, 0.998. 0.998. Pretty darn close to saying 1.0 molar units. Trick here, be sure that if it gives you a milliliter, that you turn it into a liter unit before proceeding to solve your problem. Using molarity in calculations, what it's doing is showing the relationship between moles of solute and the liters of solution. If I see 2 molar, the solution contains 2 moles of sugar for every liter of solution. If I had 2 liters, it'd be 4 moles per liter per that volume of solution. So it's really just a concept of saying every 1 liter has a certain number of moles. I have twice as many moles if I doubled the volume. Let's consider that in the following question. How many liters of 0.125 molar sodium hydroxide contain 0.255 moles of NaOH? Here's what we know. We've drawn it several times. Moles of solute per liter of solution is big M molar units. The round little buddy is nice. It's just an algebra trick. Since we're being asked to solve for liters, that's the variable I cover up. And now I can see literally what to calculate to pull out liters. Moles divided by molarity solves for liters. It's that simple. 0.255 moles of sodium hydroxide. On the bottom must go the molarity unit. And literally, if I defined molarity as moles per liter, look at what I've done over here. I want the moles to cancel, so I put it on the bottom. And that will pull out the liter. Because the very definition of concentration is that there's 0.125 moles of solute in every 1 liter of solution. Just really thinking about molarity in terms of its units, mole per liter, I can see how dividing the two, mole over molarity, pulls out a volume unit. The moles of solute cancel, and it brings you to the volume liter. Moles divide by molarity. 0.255 divided by 0.125 gives me a volume of 2.04 liter units. And my label would be sodium hydroxide. In our next example, we have a new target variable. Determine the mass of calcium chloride, given the molar mass there of 110.98 gram units. We dissolved that in 1.75 liters, and we received a 1.5 molar solution. All right, we want to know mass. Couple of ideas. We know mass, measured in grams, divided by molar mass, mm for molar mass, represents the unit called mole, grams per molar mass. We also know that moles per liter is big M molarity. This is what we're ultimately solving for. The common unit that brings me from one to the other is the mole. What I know is the liters. I know molarity. If I can solve for mole, molarity times liter brings out moles. I can place that down here, mole times molar mass, and pull out a gram. Let's begin this journey. We'll start with 1.50, and that's a molar unit. I'm going to choose to write that as moles of calcium chloride per liter of solution. I write molarity by definition. Then I can see if I cross multiply by the volume, 1.75 liters, just set that over a 1. Notice what's happening? The liters have canceled and I'm at the mole. That mole was found by taking molarity times liters. Molarity times liters cancels the liter unit. That mole can now be found using the molar mass. And they've done that for us. Here's what we know. Every 1 mole of calcium chloride would weigh 110.98 grams, the formula weight of rock salt, calcium chloride. Notice now, moles cancel and we're at the mass unit. All we've done is said that mole number times molar mass pulls out grams. This dimensional analysis helps me see unit cancellation. So step 1, molarity times liters. 1.5 molar times 1.75 liters. That pulled out the mole number. From there, mole times molar mass, 110.98, and I found 291.3 grams as the mass of our solute calcium chloride. How would you prepare a 250 ml of a 1 molar copper 2 sulfate pentahydrate solution? It's asking me very similar to that picture we looked at a moment ago. How much would you weigh out to dissolve into 250 mils to get a 1 molar solution? So let's go to work calculating. We want to know a total volume of 250 mils. If 1 molar solution, 1 molar means in every liter, there's 1 mole of copper 2 sulfate. So let's begin by just set a comparison. If 1 molar solution, and I have to weigh out my copper 2 sulfate, the reason I was just kind of thinking in my head, this pentahydrate tells us it's a hydrated crystal. The molar mass is found by taking copper at 63.5, adding a sulfur at 32, adding an oxygen times 4, so that would be 16 times 4. That actually gives me like 159.5, but I'll hit that just to be sure. Yeah, 159.5. But in addition to that weight, we have 5 water molecules. That little dot means attached to it as part of its structure. We called that a hydrated crystal. We actually did an experiment with that very idea last class together. So water has a molar mass of 18, but there's 5 of them, giving me an additional 90 grams. And that's where the 249.69 comes from. Taking the 90 and adding the 159.5 gives, multiplied, I'm sorry, 159.5 plus 90 gives us this molar mass of the hydrate. So I'm sure that, I know I'm rambling a little bit, but if they didn't provide me with this molar mass and we actually had to calculate it, keep in mind the little dot means to do not multiply, but add on the water weight. All right, just a reminder of hydrated crystals. How many grams do I need? Grams over molar mass, 249.69 grams per mole, to prepare 0.25 liters